Howdy dowdy, it is your host Aphelion, and welcome back to the Ephemeris podcast for all my returning viewers. If you're a new viewer, hi, this is a astronomy podcast, and I hope you stick around to hear a little bit more about it. And we are currently in season 2, covering some more historical cosmology, but if you want to check out season 1 for some more stuff on celestial objects, that's also there. But yeah. The reason for me giving that intro today would be due to the fact that a lot of my viewership tends to happen in the first 30 seconds. So, yeah, just wanted to make that a little bit of an intro to some of the newer viewers. But if you're returning, you know that we're currently in antiquity and we're talking about some of the astronomers during that time before we get into the Middle Ages. And the last person we have to cover, I think, for antiquity would be Aristarchus, which I promised to cover in the last episode. And so let's get straight into the introduction of the man himself. He is a 3rd century BCE astronomer, so we're rewinding the chronological clock just a little bit to make it make sense, because Ptolemy was about a century into the current era, whereas Aristarchus is not. He was a disciple of Strato, who supposedly taught him in Alexandria despite being based in Athens. And unfortunately, Aristarchus' work has been mostly lost, like quite a lot of the other astronomers, except there's one piece that remains that I think is still an Arabic translation, if I remember correctly. And it's titled On the Sizes and Distances of the Sun and Moon. And also there are some references from Archimedes. Hopefully I'm saying that right. And those references also kind of help us understand what kind of work Aristarchus did. So the claims that are made in about the theories that Aristarchus proposed are often speculative, which I kind of want to preface because I think that's going to come, like some of the claims that he made are that are speculative are going to come up very soon. So yeah, I just wanted to preface that. But I think it's still worthwhile looking into his work. There is quite a lot of value to dig into. So let's dig in. On the sizes and distances of the sun and moon, the piece itself is believed to be an early work of Aristarchus because he did some calculations under the assumption of a geocentric model. So originally he was under such an impression. So then the question comes, I think I've mentioned this before, the fact that he was a heliocentrist. Like, why do we think that he's a heliocentrist if the one work that remains seems to be done under the assumption of a geocentric model? Well, that would be mainly due to the references that Archimedes made in the Sand Reckoner, which is one of his own pieces. And the main quote that describes Aristarchus' theory goes like this. But Aristarchus has brought out a book consisting of certain hypotheses, wherein it appears as a consequence of the assumptions made that the universe is many times greater than the universe just mentioned. His hypotheses are that the fixed stars in the sun remain unmoved, that the earth revolves around the sun on the circumference of a circle, the sun lying in the middle of the orbit, and that the sphere of fixed stars, situated about the same center as the sun, is so great that the circle in which he supposes the earth to revolve bears such a proportion to the distance of the fixed stars as the center of the sphere bears to its surface. So that's a pretty long quote, and it got confusing at the ending, so let's break it down. Basically, what is here to take away is the fact that Aristarchus said that the sun is stationary at the center of the universe and in the middle of Earth's orbit. And there are also fixed stars that are stationary, but they're between the Earth and the sun. And the fixed stars create a sphere large enough that the distance between Earth's orbit and the fixed stars is the same as the radius of the sphere of fixed stars. So that's basically what that quote is, and it's kind of interesting that he does put the fixed stars between the sun and the earth. So, now that we understand Aristarchus' heliocentric theory, let's talk about his calculations, because I think that's where the bulk of his work was. Because he understood that the moon's light was reflected off the sun, he was able to conclude that when a half moon occurred, the sun, moon, and earth formed almost a right triangle. And the half moon is created by the fact that the sunlight falls exactly perpendicular to our direction of view of the moon. And basically, he kind of took this idea of reflecting sunlight and he calculated the angle of reflection to be 87 degrees, but it was off. It's we currently calculate it to be 89 degrees, and I think the way that they calculate that angle of reflection, they wouldn't have been able to do it 2 millennia ago. So yeah, his calculation was slightly off, and he used that angle measurement to calculate the distance from the sun to the earth and the moon to the earth, so this made his numbers way off. And he ended up saying that an astronomical unit, or the distance between the sun and the earth, was 20 times the distance from the moon to the earth when it was actually like 390 times. And now you might think, how does 2 degrees of error create that much of an inaccuracy when you calculate? Well, 2 degrees is equal to 4 moon diameters from our point of view when we look up in the sky. Like the angular diameter of the moon is half a degree. And if we convert that to distance numbers, 2 degrees, that would be 8,640 miles, right? So you take 4 moon diameters, that's 8,640 miles. And that's when an object you observe is really close to you. So if you want to really kind of soak in the inaccuracy of 2 degrees, you might think about, well, what if I made a 2-degree error when you're observing something really distant, like maybe a quasar, right? So yeah, 2 degrees in of a miscalculation in the sky is pretty large. And to add on to that streak of unfortunate miscalculations, he concluded that the diameter of the Earth was 2.85 times that of the moon, but in fact the factor is about 3.67. And he found the sun's diameter to be between 6.3 and 7.2 times the diameter of Earth, while the diameter of the sun compared with that of Earth is actually 109. So I think really what I'm trying to bring to light here is the fact that Aristarchus was let down by the incapability and inaccuracy of his measurements, and obviously the fact that it was the 3rd century BCE plays a part in that. And there's this weird feeling inside me. I want to believe that if Aristarchus had the right tools, he would have been one of the most revolutionary astronomers of antiquity, rather than, say, your Philolaus or your Hipparchus, because those are the other 2 great mathematicians of that era. And he was known for have created like his own sundial of sorts, but like the armillary sphere, which is a very, very helpful astronomical tool, came around like 1800 years after him. Like, imagine what he could do with something like that, technology like that. I don't know. I feel like that's just me. But also, moving on, Aristarchus, if his calculations were valid, could have outdone Hipparchus, because Hipparchus believed his calculations sided with the geocentric model. So if Aristarchus had those calculations down with his heliocentric model, I think he would have had a 1-up. But maybe it just wasn't meant to be. And so, other than that, there's not much else for Aristarchus. Most of his kind of remarkable work comes in the fact that he predicted a heliocentric theory like 1800 years before, Copernicus came around, and then a couple more years before Isaac Newton came around and actually like solidified a heliocentric theory. So yeah, he was a huge influence to, again, Copernicus, even though Copernicus refrained from mentioning him in his work. But otherwise, he was pretty much ridiculed and condemned for his heliocentric belief by most other astronomers from antiquity, because as we know, throughout this season, we've been talking about astronomers who believe in the geocentric model, and that's kind of what he was surrounded by. And the only one who didn't was, I hope I say this correctly, Seleucus of Seleucia. And he was said to have proved him right, but we don't know that for certain. Again, some of these claims are speculative. So, really, in essence, Aristarchus's beliefs were rejected for around 1700 to 1800 years, even though he was way ahead of his time until, Copernicus came around and redeemed his model and all of that. So yeah, that I'm pretty much done with all I have to say about Aristarchus. That is the episode for you guys. Hopefully you enjoyed it. If you did, I would sincerely appreciate a follow on Spotify. If you are listening on Spotify, if you're listening on YouTube, which is where most of the viewership occurs, thank you very much for making it to the end, because I notice my viewership tends to drop around 30-second mark, and I think I mentioned that at the beginning of the video. Yeah, if you did and you enjoyed the episode, I would appreciate a subscribe. And until I think I'm gonna release a double episode, or 2 episodes this week, so hopefully a podcast episode will be coming to you on Wednesday. And until then, I will see you all later. Peace.